Hello, you are watching Being Mathematician. In this video, I am going to discuss rational number and irrational number and its applications with illustrative examples. So without any further delay, let's start the video. At first, let's have the definition of a rational number. A rational number. A number is called a rational number when it can be expressed as P by Q form, where P and Q are any integer, and obviously Q is not equal to 0 because any number by 0 is undefined. Now, the example of rational number is like that. Five can be expressed as 5 by 1. So here P is 5 and Q is 1. So 5 can be expressed as 5 by 1 or P by Q form. And minus 7 can be written as minus 7 by 1, assuming minus 7 is P and 1 is Q. Say T is also expressed as P by Q form. In the case of 0, we can write 0 as 0 by any number. So 0 assuming as P and n assuming as Q. So 0 can be expressed as P by Q form. Let's see the more examples. 2.5 can be written as 25 by 10. Here 25 is P and 10 is Q. So 2.5 also expressed as P by Q form. 7 by 10. Here 7 is P and 10 is Q. So 7 by 10 can be expressed as P by Q form. So we can say any integer, decimal, 0, is a rational number. Now let's see some applications on rational number. Find rational numbers between the numbers minus 1 by 12 and 2 by 3. So there is 3 ways to determine the rational numbers. Way 1. This way is very simple. Just one number to get one number. Add this number and divide it by 2, and this will be 7 by 24, which is between minus 1 by 12 and 2 by 3. Second number, another number it's not second, another number. In the same way, adding 7 by 24, this number, plus 2 by 3, you can choose minus 1 by 12, there is no problem in that, by 2, and we will get another rational number, that is 23 by 48, which is between minus 1 by 12 and 2 by 3. So in this way, we can find infinite numbers of rational number between minus 1 by 12 and 2 by 3. Now we have to go to the way 2. The given rational numbers are 1 by minus 1 by 12 and 2 by 3. Just one number. To get one number, we apply this process, minus 1 plus 2, just adding their numerators and as well as adding their denominator. Then we will get the number 1 by 15, which is between minus 1 by 12 and 2 by 3. Another number. In the same way, we adding 1 and 2. 1 plus 2. Here 1 and 2, and in the place of denominator 3 plus 15. So the number will be 1 by 6, which is between minus 1 by 12 and 2 by 3. So applying the process again and again, we can find infinite numbers of rational numbers between minus 1 by 12 and 2 by 3. Now let's see the way 3. The given rational number is minus 1 by 12. So, and 2 by 3, and now LCM of 12 and 3 is must be 12. So 12 is multiplied by 1, then we'll get 12, and minus 1 is multiplied by 1, that will be minus 1 by 12. Convert the denominator in one number, that is the LCM of the numbers. So 3 is multiplied by 4, then we will get 12. So 2 also multiplied by 4, and we get 8 by 12. So let's see in the number line, here minus 1 by 12 and here 8 by 12. So we can fill the numbers between them by just changing the position, changing the numbers in the numerator place. So minus 2 by 12 minus 3 by 12 minus 4 by 12, 0, etc. There are infinite numbers between minus 1 by 12 and 8 by 12. So this is one number, this is another number, this is another number. So we can find infinite number of numbers in this way between minus 1 by 12 and 2 by 3. Now we move to our next section, that is irrational numbers or surds. Let's start. Let's start our second section, irrational numbers or surds. Let's keep clear the definition of an irrational number. Nth root of a is called a surd when number 1 n is always greater than 1 and n is a positive integer. Number 2, the number nth root of a cannot be expressed as p by q form, where pq are integer and q not equal to 0. That means the number nth root of a cannot be a rational number. Number 3, a must be a rational number. Now, let's see what is like and unlike surds. The example of like surds is like that 2 root 3 minus 5 root 3 1 by 7 into root 3. Observe that the root part of the numbers are same in these three numbers. So when this irrational parts of the number is same, then the surds are called like surds. And what is unlike surds? Let's see the example. Root 7, root 5, 2 root 35, 1 by minus 5 into root 2. Here, the irrational part of a surd is different from the other. So, this type of surds is called unlike surds. Now, let's see the operations on surds. Rule number 1. B root A plus minus C root D is equal to B root A plus minus C root D. That means addition or subtraction cannot be happened in like surds, in unlike surds. So here we can observe that the surds are unlike surds. So addition or subtraction cannot be done in unlike surds. So example, 3 root 5 plus minus 7 root 2 is equal to 3 root 5 plus minus 7 root 2. Now, let's go to rule 2. In the case of like surds, we can observe that a root b plus minus c root b is equal to a plus minus c into root b. Let's see the example. 5 root 7 plus minus 8 root 7 first we see the addition, that is 5 is added to 8, that means 13, and root 7 is remain same. And now see the subtraction, 5 root 7 minus 8 root 7. As same as addition, 5 minus 8 is minus 3, so it will be minus 3 root 7. Remember, the irrational part of the number is remain same after addition or subtraction. Now let's see the rule number 3. Rule number 3 about multiplication of surds, that is a root b into c root d, it will be a into c and b into d. To realize this rule, we have to see the examples. 3 root 5 into 7 root 2, it will be 3 into 7 root over 5 into 2. So it will be 21 root 10. Remember this note, that is a cube root of b into c fourth root of d is equal to ac cube root of b into fourth root of d. Let's discuss some important note about these operations, about these rules. Note: even number ith root of a negative number, suppose minus x, we can say about this term that one value of the term is an imaginary number, and oddth root of a negative number, we can say all value of the number is pure real. Now let's see the another notes. A surd multiplied by rational number must be a surd. Surd divided by rational or rational divided by surd, both of the case it will be a surd. Surd plus minus rational or rational plus minus surd must be a surd. Next one, surd to the power rational number. It is either surd or rational. Now rational to the power surd, it is a obviously surd. Surd divided by surd or surd into surd or surd plus minus surd. In all three cases, it will be a rational number or surd. Now let's see our next topic. Let's discuss about pure surds and mixed surds. Pure surds. Let's see the example first. The general example is nth root of AB. The numeric example is cube root of 5, 7 root of 2, etc. And mixed surds is a into nth root of b. Numeric example is 2 into cube root of 5, 3 into fifth root of 2, 6 into sixth root of 2, etc. That means in mixed surds, one number is rational and one number is irrational. But in pure surds, the number is completely irrational. There is no rational number. Now let's see how to convert a pure surds to mixed surds. Let the number is cube root of 24. Now factorize the 24. We get 2 into 2 into 2 into 3. So from these 3 2's we get 1 2 out and write the remaining part. So it will be 2 into cube root of 3 and it is a mixed surds. Now let's convert mixed to pure. Let us assume that our mixed surd is 5 into cube root of 2. So cube root of 5 cube into 2. So cube root of 125 into 2 and the pure surd will be cube root of 250. Now we have to discuss about a very important topic, that is conjugate pair of a irrational number or surd. We take two types of surd. One is a minus root b and another is root a plus root b. In the case of this surd, the conjugate pair is a plus root b, and in the case of this type of surd, the conjugate pair is minus root 2 plus root b or root a minus root b. Let's see the numeric example. Conjugate of root 3 minus root 5 is root 3 plus root 5 or minus root 3 minus root 5. So I think you can understand the conjugate pair concept of a surd. Now, at last, we have to discuss very important topic, that is how to do rationalize a surd. So our topic is rationalization. Let's see how to do rationalize a surd. First of all, we have to memorize the formula a square minus b square equal to a plus b into a minus b. So let's follow the simple steps. First, form a plus b into a minus b, then write a square minus b square. So in this way, we can rationalize an irrational expression. Let's have a numeric example. Example 1. Rationalize the denominator root 3 plus root 2. So, to form a plus b into a minus b, we can multiply by root 3 minus root 2 on numerator and denominator both. So, this is clearly this form. So now, write this form. So root 3 square minus root 2 square, root 3 minus root 2. So it will be 3 minus 2 and root 3 minus root 2. So this is root 3 minus root 2. So we rationalize the denominator in the fraction 1 by root 3 plus root 2. Let's see example 2. Rationalize the denominator of the fraction root 5 plus root 2 by root 3 minus 5. So clearly we can multiply numerator and denominator both by root 3 plus 5. So clearly we can do this multiplication, then it will be root 15 plus root 6 plus 5 root 5 plus 5 root 2, and in the place of denominator it is root 3 square minus 5 square. So the final answer is minus 1 by 22 into root 15 plus root 6 plus 5 root 5 plus 5 root 2. I think this video helps you to clear your concept about rational and irrational numbers. So see the video again and again and do the exercise alone. If you realize that this video is really necessary to everyone, then share it as much as possible. So good luck, goodbye.